If the United States kicked its fossil fuel energy habit, could it run cleanly, efficiently, and cost-effectively using alternative energy? Could there potentially be so much cheap alternative energy that U.S. industry could rise to world dominance once again? We talk with one local energy engineer studying energy storage and production who says yes on Newsmakers. Imagine a world of electric cars or some other alternative vehicle with windmills, not like the ones you see now, and energy stored like it's stored in a grandfather clock. This is the future of local inventor and energy engineer Brad Kallio. He owns a company called Zynoc. It's located in Granville. Brad, thank you for joining us.
Thank you. Glad to be here.
Last fall, you had a gathering of electric vehicles out in Granville during the Metro Cruise, and I know you'll be out there again this year. Yeah. And that's when you first popped up on the radar, and since then I've had a chance to walk your grounds out at your Walker location. It's really fascinating stuff that you've been working on. Tell me a little bit about yourself and how you got interested in alternative energy and energy storage.
Wow. Loaded question as usual. Well, back when the tsunami hit Indonesia, that big wave wiped everybody out, and then Hurricane Katrina shortly thereof, it occurred to me that there was something up. I mean, it was weird, and so I started doing a little research into it, and I realized that we needed to have homes. If our world is going to continue to change, we need homes that will sustain. Someplace that would be able to survive harsh environments, because that's changing, especially like in Louisiana and those kind of areas. So I came up with an idea for a home that looked kind of like an onion. I called it Enviro House. Searched for materials and so on, and then I ran into this guy named Paul Walker, who's a physicist, engineer, and we started building phase converters, and because he was a materials engineer, I asked him about the problem. And he goes, oh, we'll use this, something I invented back in 1984. It's been classified, but now it's so old it doesn't matter. It's called gypsum foam. Still not in circulation for some weird reason, but it's a wonderful material. It looks like shaving cream when it comes out, and it hardens like plaster of Paris. But because of the material it's made out of, it's lightweight, it's very hard. You put a nice coating like a 11 mil Mylar on the outside of it, you got almost a bulletproof wall. If you ever try to tear a Mylar balloon, it's very strong. Anyway, but he was doing magnetic research trying to develop a AC battery. Not a chemical battery, but a crystal battery. So in turn, scientist to scientist, I started helping him with that project. I got pretty much most of the details of what I needed to do with Enviro House figured out. And now it's a home that basically, once it's in production, it's a manufactured home, like any other manufactured home, except for it comes in 36 pieces. And you can assemble 2 or 3 of them a day with a crew of maybe 5 people. But it's got a water filtration system put in the basement, in the bottom of it, so that the water coming out is cleaner than it was when it went in. It powers itself. So basically, it's a self-contained system. It'll handle 300-mile-an-hour winds, 150-mile-an-hour impact from like a 2x4, and all the parts are replaceable. So if you do get one that is damaged in a big storm, you just ask for another one, they ship it out to you, you yank it out, put a new one in, and now it goes back to be recycled. Because it's gypsum, you just grind it up. Anyway, little problems like that were really easy to solve, but the big one was the energy system. That one started to really puzzle me, and as more things evolved, I realized that that was the biggest issue we have right now is energy, because as long as we're doing things as man that are causing problems in our environment, it's going to continue to get worse. And fossil fuels definitely have become an issue. I mean, there's a movie called Crude, an ABC special, and they talk about how addicted we actually are to petroleum. And when you look at the fact that you come out of your mother's womb into a pair of latex gloves, it kind of says something to you, how just deep it goes. It's in our food, vitamins, our clothing, it's everywhere. So looking at what's changing, I realized we had to start developing an energy system that would be able to accommodate, and hence I realized there was a way to store energy. I went to Ace Tool and Engineering, where I do a lot of robotics controls work for them, and I went to Eugene and says, hey, I've got this wheel here, and can I borrow some little pieces of steel to make weights? I'm experimenting to see if I can make a clock, basically, that would store energy, just the same way a grandfather clock does work. And he says, sure. And I went home, started working on my little model made out of paper, the same stuff I made the EnviroHouse out of. He calls me up that night and says, Brad, get your butt back in here tomorrow. Okay, why? He says, well, your little wheel got my gears moving. Pardon the pun, but it was a funny moment. And he and I sat down, and within 2 hours in the office, we completely developed a energy storage system. He thought it might be able to be almost perpetual, and it's close. It's very close to perpetual motion. Not quite, but it's close enough that there's very low loss, and that's what you're trying to achieve. But because the energy is coming from wind, solar, hydraulic, and other systems, it doesn't matter. It's free. It's okay. So a little loss is acceptable when you've got an enormous amount of energy coming in. And then it's just been research and development from there, and then we realized that the generator storage system wouldn't work because all the generators that are available don't move slow enough to be effective for Mother Nature's use. Everything's based around petroleum, so all the generators available today are 1100 to 1800 RPM. The time you take wind moving at 2 or 3 RPM and try to convert that into something that fast, you have no energy left. It's all been sucked up in your gearing. So the next step was to build a generator. Since you can't find them, farm rules are if you can't find it or buy it, you build it. So we built one. Well, actually, I built a little one, then I built a bigger one, and then we built the one that you saw at the shop the other day. That one's now in the back of the trailer, or should be by the end of the day today.
What kind of capacities are we looking at here? I mean, how much energy can that store and produce?
It's all scalable. It depends on how big of a system you're working with and how much area you're collecting. Energy works on, or wind energy especially, works on pounds per square inch. The more square inches of energy you have, the more energy you're going to collect. The bigger the sail, the faster the boat goes. So when you put like a 4-foot by or 6-foot by 10-foot blade or sail out there on a 10-foot arm, at 5-mile-an-hour wind, you get 2 pounds of force per square foot. At that distance, you're roughly between 12 and 1,500 foot-pounds of torque in 5-mile-an-hour wind with a sail that big on a 10-foot arm, because you get your gain of torque every foot away. So 1,500 foot-pounds of torque is almost 3,000 watts. It's like, you know, somewhere around 2,500 watts or a little over that. So that's a lot of power in very low wind, which means it'll work anywhere in Michigan with a sail that size. Now, if you want to go to a bigger system, put one on the top of a building out here in Grand Rapids. Make it 50 foot in diameter. Put a 100-foot blade on the end of it. Now you're talking, you know, tens of thousands of watts. It goes up from there. They've got generators and energy storage systems where they're using magnetic bearings and are spinning, you know, 50-foot wheels with big weights on them, and they're floating on a magnetic field in a vacuum. Now they get that wheel spinning, and they store that energy in that. And they just increase the speed of the wheel until they do it, or until they need it, and then they can draw that energy back off the wheel. Sorry.
No, that's okay, because you talk about using magnets, and that seems like a very old idea, but magnets have been around for a long time.
Nothing I'm doing is new. Most of this stuff goes, the grandfather clock idea, the Romans did this stuff thousands of years ago to pump water. Only thing different is that you have to be able to change that energy into electricity, but electricity is still plumbing. Pounds per square inch of energy going through a wire. The only difference is water, you can get too much pressure in it, it'll burst the line or burst the hose. Electricity, you get too much pressure in it for the size, it gets hot and melts things and burns houses down. But as long as you keep it within the limits of tolerant, you know, it works just fine. You don't have to worry about that.
But can we sustain a society with the millions of people on this planet without petroleum?
Yes. Okay, right now we have central located generator plants. They pump the energy up to 300,000 volts and send it out over these lines. Bring it into transformers, bring it down to 220 volts for you and I to work with. The problem is that if that system goes down or those lines go down, people freeze to death in the winter because they lose power. And look what happened in Kentucky a couple of years ago when they had that big ice storm.